Welcome everyone. Today I'll take one more class for the topic increasing and decreasing function. So look, problem number 3. G minus infinity to plus infinity to minus pi by 2 to pi by 2 is a function given by this. Then G is even and increasing, odd and increasing, odd and decreasing, none. So which option is correct? So GU equals to 2 tan inverse e to the power u minus pi by 2. So we have to prove it first whether it is even or odd. So this is tan inverse e to the power u, cot inverse e to the power u. Pi by 2 equals to, so this is tan inverse e to the power u minus cot inverse e to the power u. Now g of minus u, tan inverse e to the power minus u, cot inverse e to the power minus u. So this is cot inverse e to the power u. Tan inverse 1 by x equals to cot inverse x. This is again tan inverse e to the power u. So if you take minus common, tan inverse e to the power u, cot inverse e to the power u equals to minus gu. Therefore, G is odd function. G is odd function. So we are getting one option, that is G is odd. Now we verify whether it is increasing or decreasing. So for this, G dash u 2 by 1 plus e to the power u whole square into e to the power. Now you know exponential function is always positive for all values of u. So this is greater than 0. So Gu is increasing. Gu is increasing function. So we are getting two options. One is odd function and increasing part is very simple. So odd and increasing. So option number 2. So fx, gx is odd and it is obviously increasing. Now question number 4. Find the value of a for which the function is decreasing for all real x. So we have also solved similar like problem in part 1. So decreasing. So f dash x 3 into a plus 2 into x square 6ax 9a. So differentiating. So for decreasing function f dash x less than 0. So a plus 2 into x square minus 2ax plus 3a less than 0, dividing by 3. Now value of the expression is negative. Value of quadratic expression is negative. So look at the theory. Ax square plus bx square plus c, this fx. So we know fx less than 0 if a less than 0 and d less than 0. So fx less than 0, this type. No root, so therefore discriminant less than 0. So it is less than 0, negative, so it is downward, this part. So here this expression is negative, therefore a plus 2, this is less than 0 and d less than 0. So a less than minus 2. We are getting a less than minus 2. And what is d? 4a square minus 4. A is 4a square minus 4a into c. So finally we are getting 4 cancel, a square minus 3a square. A square minus 3a square minus 6a less than 0. Less than 0. So minus 2a square minus 6a less than 0. So a into 2a into a plus 3 less than 0. So less than, so this will be greater. This is 4a square, 4. This is negative. So this is greater than 0. So this one is greater than 0. So what we are getting? We are getting two values of a. So this is 0 and this is minus 3. So a belongs to minus infinity to minus 3 union 0, infinity. So we are getting one condition from here and one more condition, that is a less than minus 2. Now we have to find common part. So if we draw the figure, so this is minus 3, this is minus 2, this is minus 3, this is 0. So a belongs to minus infinity to minus 3 and 0 to infinity. And second one is a less than minus 2. So what is the common part? Common part is this one, less than minus 3. So decreasing in, answer will be x less than minus 3. That is minus infinity to minus 3. So what is our common part? Common part is x less than minus 3. So x less than minus 3 is common part. So x less than minus 3, that is minus infinity to minus 3. So x belongs to this. So it is decreasing when minus infinity to minus 3. So this is most important problem. So f dash x for decreasing less than 0, we are getting this in equation. So from this, value of a lies between this. If it is greater than 0, outside the interval, and one more condition at the beginning, a less than minus 2. So common part is minus 3. X less than minus 3 in terms of interval, we can write this in this form. Now we consider is a typical problem number 8. The function sin x by x is increasing in which interval? So fx equals to sin x by x. So f dash x by quotient rule, x into cos x minus sin x. Now denominator is always positive, and numerator you are not sure. So look, it is minus, so you cannot conclude that it is negative or positive. So for this type of problem, we consider again another function. Suppose gx equals to x cos x minus sin x. So this one is obviously positive. So we consider this as gx. Now g dash x into sin x plus cos x minus cos x. So minus x sin x. Now in the interval 0 to pi, in the interval 0 to pi, so sin x is positive, x is negative. So 0 to pi, x belongs to. So g dash x less than 0, because it is positive and x is positive negative sign. So gx is increasing, in 0 to pi. So look at the nature. We need a result here. If it is decreasing function, this is g0 and these are gx. So what we are getting? Gx less than g0, because this is gx, this is gx, this is gx. So sorry, for decreasing. So less than 0. So gx is decreasing function. So gx less than g0. Gx less than g0. Now what is gx? X cos x minus sin x less than 0 into cos 0 is 0, sin 0 is 0. So this is 0. X cos x minus sin x less than 0. So now we conclude from 1 that numerator is negative and denominator is obviously positive. So this is 2. So from 1 and 2 we can conclude f dash x less than 0. So this is negative, this is positive. So fx is decreasing in 0 comma pi. So fx is decreasing in 0 comma pi. Now here it is given increasing. So if it is decreasing, then answer will be 0 to pi. Now second condition. Look, in pi to 2 pi, look, in pi to 2 pi, x is positive, sin x is negative. So total is positive. So g dash x greater than 0. So dx is increasing function. In pi to 2 pi, so g dash x greater than 0. So gx is increasing. Now for increasing function, figure will be like this. So these are gx. In this case, gx greater than g0. Therefore, x cos x minus sin x greater than 0. This is 2. This is 2. So from 1 and 2, f dash x greater than 0. So fx is increasing. Fx is increasing in pi to 2 pi. So pi to 2 pi, if it is increasing, then pi to 2 pi. So pi to 2 pi is our correct option. So 0 to 2 pi, so it can be written as 0 to pi union pi to 2 pi. So in this interval it is decreasing, in this interval it is increasing. So to the whole interval it is neither increasing nor decreasing. So B is our correct option. So B is our correct option. Now listen again. F dash x. So we are getting two terms having one positive, one negative. We cannot conclude that this is positive or negative. In this case, you take one function here. Then if it is increasing, then condition is gx greater than 0. If it is decreasing, gx less than 0. So this is typical problem. Now problem number 9. So what is f dash x? 2 plus cos x whole square. 2 plus cos x into 4 cos x minus 4 sin x into 0 minus sin x minus 1. So 2 plus cos x whole square. So 8 cos x minus plus 4 cos square x, 4 sin square x. 8 cos x. So 4 cos x, 2 plus cos x minus 4 sin x unchanged. So 0 minus sin x. So this is 4 sin square x and this is 4 cos square x and this one is minus. So if we simplify, 2 plus cos x whole square, 8 cos x plus 4 plus minus 4 plus 4 cos x plus cos square x. Expanding. So 8 cos x, 8 cos x. So 8 cos x minus 4 cos x. So finally what we are getting? Look, 4 cancel. 8 cos x. 8 cos x. So 4 cos x minus cos square x by 2 plus cos x whole square. Now it is cos x common, 4 minus cos x by 2 plus cos x whole square. Now listen, 4 minus cos x is obviously positive. So 4 minus cos x is always greater than 0. So cos maximum value is 1. Now denominator is always greater than 0. Denominator is positive. So it depends on the sign of cos x. So increasing. So for increasing function, f dash x greater than 0. So what we are getting? Cos x greater than 0. For increasing, f dash x greater than 0. So this one is positive, this one is positive. So cos x greater than 0. So now we look, cos x is positive in which interval? Obviously it is in first quadrant. It is negative here. Some 0 to pi by 2 positive, pi by 2 to pi negative. So only one option, that is 0 to pi by 2. So this is very simple problem. Now I consider two more problems. These are problems of IIT. So f is positive increasing function with limit x tends to infinity f3x by fx1, then f2x by fx equals to what? Positive increasing function. So this is x, this is 2x, this is 3x. So since fx is positive increasing, increasing function, তাহলে fx less than f2x less than f3x. So fx, this is fx, f2x, f3x, fx less than f2x less than f3x. Or we can write one less than f2x by fx less than f3x by fx. So limit x tends to infinity 1 less than limit x tends to infinity f2x by fx less than limit x tends to infinity f3x by fx. So this is 1. This is limit x tends to infinity f2x by fx less than 1, because this one is given as 1. So this one is 1, this one is 1. So therefore, by sandwich theorem, so this limit is also 1. Limit x tends to infinity f of 2x by fx equals to 1. So fx is positive increasing. So look, fx less than f2x less than f3x, divide by fx. Take limit on both sides with x tends to infinity. This is 1, this is 1. So from sandwich theorem, so we can say that this middle one is also 1. So this is simple one. Now consider problem number 11. F is a real valued function such that fx into f dash x less than 0. This is 1 marks problem of Wbjee. This one is given. That is, we can say fx and f dash x are of opposite sign. So we can conclude this. Now they are of opposite sign. Now which one of the option is correct? So suppose fx equals to e to the power minus x. So what is f dash x? Minus e to the power minus x. So here e to the power minus x, it is always positive. This is greater than 0, and due to negative sign, this is less than 0. So fx and f dash x are of opposite sign. So this satisfies given condition. So we can say fx is increasing function. Sorry, fx is decreasing function. Now case 1, suppose this is case 1. Case 2, so suppose fx equals to minus this. So what is f dash x? So it is e to the power minus x. So this is negative, this is positive. So here also this condition is satisfied. So what we can say? So fx is increasing for all x belongs to R. Here also for all x belongs to R. Now, so fx may be increasing may be decreasing also. Now, if we take mod fx, so here fx equals to e to the power minus x. Here fx equals to this. So, mod of plus minus e to the power minus x. Considering case 1 and case 2. So, e to the power minus x. This is positive quantity. So, e to the power minus x. So, ddx of mod of fx minus e to the power minus x less than 0. Less than 0. So, what we can say? Mod. Therefore, mod fx is decreasing. In all cases, we can say mod fx is decreasing. Mod fx is decreasing. So, look at the steps. This one. Mod fx equals to this. So, mod of plus minus is plus e to the power minus x. This is positive. So, e to the power minus x. So, in all cases, mod of fx equals to e to the power minus x. If we take derivative, we get minus e to the power minus x less than 0. So, mod of fx is decreasing. So, it is always true. So, option C is correct. Now, we consider problem number 13. If R থেকে R be a differential function such that f dash x greater than 2fx for all x belongs to R and f0 equals to 1, then f dash x less than e to the power x greater than increasing, decreasing in 0 to infinity. Now, one condition is given, that is f dash x greater than 2fx. So, let gx equals to f dash x minus 2fx. Therefore, gx greater than 0. F dash x minus 2fx. So, f dash x minus 2fx greater than 0. So, gx greater than 0. Now, this is ddx of fx minus 2fx equals to gx. So, solution, integrating factor e to the power minus 2 dx. So, e to the power minus 2x. So, if we multiply 1 by integrating factor, so we get ddx of fx into integrating factor equals to e to the power minus 2x into gx. Now, gx greater than 0. It is given gx is positive, e to the power minus 2x is always positive. Since gx greater than 0, exponential function is greater than 0. So, ddx of fx into e to the power minus 2x greater than 0. So, we can conclude fx into e to the power minus 2x is increasing function. So, this is increasing. So, if it is increasing function, look, this type of figure, this is f0, so they are fx. So, we have already solved this type of problem. So, it is increasing. So, gx greater than g0. So, this is not dx. So, therefore, fx, this function fx into e to the power minus 2x greater than f0 into e to the power 0. Now it is given f0 equals to 1. So this is greater than 1. So what is fx? Fx greater than e to the power 2x, because it is a e to the power 2x is positive number. So greater than in equation remain greater than. So fx greater than e to the power 2x. So fx ddx of this fx greater than e to the power 2x. So fx into e to the power minus 2x is increasing function. So if gx is increasing, then gx greater than g0. So this is fx into this greater than f0 into this. f0 is 1. f0 is 1. So 1 e to the power 0. So e to the power minus 2x is positive number. So fx greater than e to the power 2x. fx greater than e to the power 2x. Now it is also given gx greater than 0. So f dash x greater than 2fx. Greater than 2fx. So fx is always positive. So f dash x greater than 0. fx is exponential function. So f dash x greater than 0. So fx is increasing. fx is increasing. fx is increasing. So listen again. Here it is given f dash x greater than 2fx. So let gx equals to this. So obviously gx greater than 0. Now ddx of fx minus this. So this is differential equation. Linear differential equation. What is integrating factor? E to the power this, e to the power minus 2x. So ddx of fx into this equals to e to the power 2x minus gx. Now gx is greater than 0 and it is exponential function always positive. So ddx of this is greater than 0. So this quantity is increasing function. So fx into e to the power minus 2x is increasing function. From property of increasing function, we know, so this type of figure, these are fx. So fx greater than f0. Here fx is replaced by this one, f0 is this. So f0 is 1. So fx greater than e to the power 2x. So option B is correct. Now it is given that gx greater than 0. So f dash x greater than 2fx. So f dash x also greater than 0 because fx greater than e to the power 2x. So f dash x, it is always positive. So f dash x greater than 0. So fx is also increasing function. So this is also typical problem. Now we consider one more typical problem, problem number 12. If PART2 be a twice differentiable function such that f double dash x 0 for all x belongs to R, f half equals to half, f1 equals to 1, then f dash 1 less than 0 lies between half and 1, 0 to half and greater than 1. So look, two conditions are given, f half equals to half, f1 equals to 1. So let us consider a function gx equals to fx minus x. gx equals to fx minus x. Now it is given that f half equals to half. So what is g half? So f half minus half. So f half is half, half minus half equals to 0. Now what is g1? f1 minus 1. So what is f1? So that is why we are taking gx in this way. So we are getting g half equals to 0, g1 equals to 0. So fx is differentiable function, hence it is continuous. So gx satisfies all conditions of Rolle's theorem. What is condition? Gx is continuous. So fx is continuous, x is continuous. So gx is continuous. Fx is differentiable, x also differentiable. Therefore, gx also differentiable. And f half, g half equals to g1 equals to 0. So all conditions of Rolle's theorem are satisfied. Therefore, all conditions are satisfied by gx. So there exists at least one point x0 belongs to half comma 1 such that g dash x0 equals to 0. So f dash x0. So what is g dash? G dash x0 equals to, so g dash x0 equals to f dash x0 minus 1. So derivative, so this equals to 0. So f dash x0 equals to 1. So x0 belongs to half comma 1. So we are getting this condition. Now g dash x equals to f dash x minus 1. G double dash x equals to f double dash x. Now it is given that f double dash x greater than 0. F double dash x greater than 0. Therefore, g dash x, g double dash x greater than 0. Therefore, g dash x is increasing function. G dash x is increasing function. So we are getting g dash x is increasing function. So g dash x is increasing function. F double dash x greater than 0. So f dash x is increasing function. F dash x is increasing function. So f dash x increasing function. So f dash 1 greater than f dash x0. x0 belongs to half comma 1. So f dash x is increasing function. If it is f dash x, so this is half, this is 1, increasing function. So it is given that f dash x0 equals to 1. F dash x0 equals to 1. So x0 lies between this to this, half to 1, open interval. So f dash 1, so what we can write, f dash 1 greater than 1. F dash 1 greater than 1, because we have already proved that f dash x0 equals to 1. Since it is increasing, since it is 1 lies outside this, so f1 is greater than any value between half to 1. And what is the value? F dash x0 is 1. So f dash 1 must be 1. So listen again. F half equals to half. So we consider the function gx equals to fx minus x. So g half 0, g1 0. So all conditions of Rolle's theorem are satisfied by gx. So there exists at least one point x0 lying between these such that g dash x0 equals to 0. Now what is g dash x0? F dash x0 minus 1. So f dash x0 is 1. Now it is given that f double dash x greater than 0. There is no need of this part also. G dash x is increasing. F dash x greater than 0. So fx is increasing function. F dash x increasing function. So we get figure like this. So it is increasing function. So f dash 1 greater than f dash x0, where x0 lies between 0 to 1. Now we have already proved f dash x0 is 1. So f dash 1 greater than 1. Now look at the option f dash 1 greater than 1. So this will be possible option. So today we have discussed some typical problem of increasing and decreasing function in part 2. So you solve a rest of the problem given in description. So I think these problems will be useful for competitive exam. So thank you.